In this video, I will show how we can actually program with math by creating a function which tells us the number of factors a positive integer has. Here I have a function in JavaScript that works very simply. We just take an input, here it is called num, and we loop through every number between 1 and it. We then check if that number divides it using modulo, and if it does, we count it as a factor. It then returns the number of factors. Now, to create this function, there are two parts we need. Firstly, we need to create a for loop. Thankfully, Maths has one already built in, called sum. Here it is. We define our starting number by saying n equals something, like 1, and it evaluates the expression to the right. It then increments n by 1 and re-evaluates it again, with the new value, until the top number is reached. Then, it sums the results of all the expressions and gives us the result. For example, if we evaluated this, we'd get 15, which is 1 plus 2 plus 3 plus 4 plus 5. Next, what we need is an if statement. This is actually simpler than you might think. It has two parts, the condition and the action, and we just multiply them together, with the action being some expression. Basically, what we want is our condition to only be one of two numbers, 0 or 1. When it is 0, the action doesn't happen, because it all gets multiplied by 0 and becomes 0. And if it's 1, when it's multiplied, the action is unchanged. Usually we get our condition and make it so it returns 0 when it's untrue, and any other value when it is, so we can then put it in sign squared, which makes all the non-zero values into 1. We use sign as it returns the sign of a number, so -1 for negatives and +1 for positives, but it returns 0 for 0. We then square it to make all the outputs either 0 or 1. For example, let's say we want a function that gives us our input number squared, but only if it's divisible by 3, and just returns itself otherwise. Our condition would be x mod 3, which is slightly wrong as it returns 0 when true, which we need to fix. But we can put that in sign squared, to get sign of x mod 3 squared. This gives us 1 when not divisible, and 0 when it is. For example, with 6, we get sign 6 mod 3 squared, which is sign of 0 squared, or 0, but for 8, we get sign of 8 mod 3 squared, which is sign of 2 squared, or 1. We can just use a not, which is just subtracting 1, by this, to get our condition to be 1 minus sign of x mod 3 squared. This only works because sign squared ensures the only values are 0 and 1. Now, we multiply this by x squared, such that when it's true, we get our input squared. Now we need to add one more bit to account for the case when it's not true. We go back to our function which tells us when it's not true, and multiply it by x, such that it returns x when untrue. This gives our full function to be 1 minus sign of x mod 3 squared times x squared plus sign of x mod 3 squared times x. So now we can start making our function. We start by defining it as f of x, with x as our input. Now just like our code, we are going to use a sum to loop through all numbers from 1 to x. Now we need to create the condition. So our condition is x is divisible by n, and our action is to add 1. Now x mod n will return 0 when x is divisible, and any number when it isn't. So we put that into our condition, and then not it to flip the boolean, giving us 1 minus sign of x mod n squared as our condition. Now our action is just 1, so we can multiply it, but it changes nothing. That leaves us with our final function as this. And if we test it, yes, it's correct. Here is a table of values. See how 6 has 4 factors, and all the primes have 2. So if you know standard math notation, you can basically code, if you try hard enough. If you enjoyed the video, please like, comment, or subscribe. I hope you learned something new, and have a nice day.